kinetic molecular theory, you have 5 statements from gases that you have to remember. They have 0 volume. They're not attracted or repelled by each other. They're in constant, random, rapid motion. Their kinetic energy is directly related to temperature. And I'm forgetting one at the moment, but you need to know all 5 of them from the last unit. Their collisions are elastic. There are several that go along with the liquids that help us describe liquids. The first one is that liquids are fluid. Now, I don't want you to think that the word fluid means liquid. The word fluid just means that you can go past each other. So molecules are able to glide past one another. So liquids are fluids, but so are gases. So gases and liquids are both considered fluid. Liquids have a definite volume. They take up their shape. They take the shape of the container that they're in. They're in constant motion, but they're closer together and they have lower kinetic energy than gases. So we say that their motion is a slip and slide. They're more ordered because they have stronger attractive forces than gases. And the type of intermolecular force that they have does help explain some of the unique properties that some liquids have compared to others. They have a higher density than gases because they take up volume. They're harder to compress. Compress just means get closer together. So while they are closer than gases are, there's still some space there for us to squeeze them even closer together. They diffuse slower than gases. Diffuse, remember, from our last unit means to mix. So liquids will mix on their own, but they're a little slower at that than gases are. And they have surface tension. So because water has the intermolecular force of hydrogen bonding, which is the strongest force of attraction, if we think about the what water looks like, there is an attraction between this hydrogen and this oxygen. So at the surface of water, that attraction is really great. So water bugs can walk on water because the attraction is so strong and water bugs have such a light mass. Leaves can float on water. Lots of unique things. If you fill the glass of water up to the almost tipping over point, you see that bubble, which is the surface tension. So it's because of the attractive forces that liquids have give them this unique property. Solids, their kinetic molecular theory is pretty easy to understand. Their particles are very close together, so they have very strong intermolecular forces. Now that's not to say that they're all hydrogen bonding, it's just their force of attraction is happening at a greater extent because the particles are close together. They have definite shape and definite volume, so they're highly ordered. There's a pattern to it usually. They have higher density because they're so tightly packed, and the exception is water. Water's solid is less dense than its liquid, which is why ice floats in our liquid water. There are 2 types of solids. You have a crystalline solid, which has a unique pattern to it, AB, 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 or you have an amorphous solid, which means that there's no structure to it. So here we have crystalline structures. You have quartz, and then you have table salt. This SiO2 is glass, and you can see that there's no unique pattern to it. They're kind of all just attached to each other. So there's only 2 amorphous solids that you need to know: glass and plastic. There's no structure, so that's what gives glass and plastic its unique properties as solids compared to other crystalline solids. Now, crystalline solids, there's 4 types of crystalline solids. There's ionic. That means at the lattice points there are ions. You have positive, then negative, then positive, then negative, then positive, then negative, that repeating pattern. So the force of attraction that's holding them together is the force of attraction between something positive and something negative, which is called electrostatic. And it's an incredibly strong force of attraction. So they are very strong. They have high melting points. But they're also brittle. So we can break them if we hammer them. I guess strong's not the best word to say. They're very hard. There's, hardness to it. Example would, down here, if we look at our pictures, NaCl, this is actually calcium fluoride, so we have 2 white circles to every 1 green circle. That would be metallic. I'm sorry, that's ionic because of the ions involved. Metallic means it's a metal. So you have metal cations surrounded by their sea of electrons. So what holds these cations together is the sea of electrons, or our delocalized electrons, or the mobile electrons. So they're, again, very hard. They are ductile. They are malleable. They're the only solid that conducts electricity or heat. They have high melting points. Examples down here. This is an example of a metal. Alright, so one of the other properties is luster, we should say. This is platinum, so solid platinum. And then this down here would be our other metal, and that's solid silver. A network covalent, you have non-metal atoms together. The only non-metal atoms that you have to worry about forming this covalent network is carbon and then silicon oxide, where you have some sort of combination of silicon and oxygen. The attractive forces between them are London dispersion, but it's a very strong London dispersion because it's a network of London dispersion. They're incredibly hard. They're very hard substances, some of the hardest substances on Earth. Diamond. They are have very high melting points. Diamond or graphite actually conducts electricity. Diamond does not because of the difference in structure, but graphite will. So here's our diamond. So diamond is one of the ones that is made up of carbon atoms. Graphite is the other one that's made up of carbon. Sand and glass is what silicon dioxide or silicon oxides make up. So in this we quartz is the other one. Quartz is just a fancy type of sand, really. So you have those network covalents. Molecular molecules make up those lattice points. And so you have London dispersion, or you have dipole-dipole, or you have hydrogen bonding holding those things together. Remember, the only ones that are going to be hydrogen bonding is a solid that has hydrogen oxygen, or hydrogen and fluorine, or hydrogen and nitrogen. General properties, they have what we consider low melting points. They're considered to be soft. So in our pictures down here, this is right here. Oh, that's NaCl, sorry. I didn't find a picture of ice, but so water we know is one of them. This right here is carbon dioxide, so you have the solid CO2 in the graduated cylinder, and then you're pouring out the gas because carbon dioxide or dry ice sublimes very easily at room temperature.